Hello friends, welcome to engineering tutorial. So we'll continue our discussion related to basic concepts related to electrical machines. So in the previous video we discussed about hysteresis and the hysteresis curve or hysteresis loop and what is the importance of that loop. So in this video we are going to discuss about another important aspect related to electrical machines, which is the question of how the magnetic field required for the operation of electrical machines is produced. So there are two ways or two methods by which the magnetic field is generated. One is with the help of permanent magnets. Second is with the help of electromagnets, which is basically utilizing the magnetic effects of electric current, passing current through a coil wound over a core. So here we'll be discussing both of them in short, in a quick way. First we'll be discussing about permanent magnet. So a permanent magnet is basically made from ferromagnetic materials. Okay, so we have discussed ferromagnetic materials and their properties in detail in a separate video, so please watch that video. So the ferromagnetic materials, as we know, the cause of magnetism in ferromagnetic materials is their atomic dipole moments, orbital magnetic dipole moments. So the ferromagnetism, which is a strong form of magnetism, attractive form of magnetism, which retains its magnetic properties, that is because of the phenomena that the magnetic dipole moments in ferromagnetic materials, they form closed groups called as clusters or domains. Okay, this arrowhead which represents grouping of magnetic dipole moments, which we have covered it in ferromagnetic video also, ferromagnetic material. So these domains, they are aligned in random directions when the external magnetic field is absent. But when magnetic field is provided, these domains, which are groupings or clusters of magnetic dipole moments, they align in one specific direction, resulting in a strong form of magnetism. That is why ferromagnetic materials have strong form of magnetism and they retain their magnetic characteristics even when the external magnetic field is removed, which we have seen in the hysteresis video, hysteresis, which is basically based on residual magnetism. So permanent magnet are basically used for the design of various parts of electrical machines. Okay, it is the popular choice because of this strong form of magnetism, and it retains its magnetic characteristics even when the external magnetic force or magnetic field is removed. So there are different types of permanent magnets, okay, which comes in different shapes and sizes, and it depends upon the design of the electrical machines which one is used and what size of it is used. So we'll be discussing some basic types of permanent magnets. First is natural magnets. They're found in natural form in nature and they're irregular in shape and have very weak magnetic characteristics. So natural magnets are not used in natural permanent magnets are not used in the design of electrical machines, whereas artificial permanent magnets are used. So the artificial magnets, they come as bar magnets, which is a uniform thin rectangular bar like this, okay, which has a certain magnetic length from one pole to another. Then another form of magnet, which is basically the horseshoe shaped magnet, which again has south and north pole. The horseshoe magnet is also used in the design of various electrical machines, and here the two poles are drawn closer to each other. It can be drawn closer to each other also, and then we have a dumbbell shaped or ball shaped permanent magnet where it looks like a dumbbell with circular extreme ends. Then we have needle type permanent magnets, which consists of a disc, circular disc, or a platform uh, with a pivot on which a needle with south and north ends, magnetic needle, that is suspended over here on the discs, south and north is like that, and it is mostly used in the design of compass. Okay, so these are some of the permanent magnets. Now basically, depending upon the requirement, depending upon the design of electrical machines, artificial permanent magnets are used in different shapes and sizes. So here we have discussed about permanent magnets. So we have discussed about permanent magnet. Now I'll be discussing about the second way in which magnetic field is produced, which is electromagnet. So electromagnet is basically based on the magnetic effects of electric current, that when current is passed through a conductor, it produces a magnetic field. And here we have to discuss another important concept, which is we have already discussed, that how a current loop, it behaves as a magnetic dipole. So when current is passed through, let's say, a circular loop, and the upper face, from the upper side, when we look at it, it appears as if the current is flowing in anti-clockwise direction. So the upper face acquires north pole, and from below, when we look at it from the down, the current appears to be flowing in clockwise direction. So the lower face, lower side, it acquires south pole, and this is the resultant magnetic dipole moment, which is given by the product of the current and the area of the current loop, the coil loop. This is for a single turn Ia, and for n turns of coil, the magnetic dipole moment is given as Nia. So similarly, for the construction of electromagnet, what happens is that here a conductor is taken over which a number of turns of coil is wound over it. Current is passed through the coil. So as a result, for n turns of coil, it behaves as a current carrying loop, and it produces a magnetic dipole moment Nia. So it can be designed in any way, in the form of a U-shaped conductor or a straight shaped conductor, depending upon the requirement, the shape, the installation. Depending on that, the shape of the electromagnet can be adjusted. So one important characteristic which differentiates electromagnet from permanent magnet is that permanent magnet, they retain their magnetic characteristics, but electromagnet loses its magnetism as soon as the current is stopped. Okay, so there are different factors which affect the strength of the electromagnet. So first is how much current is passed here, which is evident from this. It is the dipole moment is directly proportional to the current. So first will be, the greater the strength or more the electric current which is passed, the strength of the electromagnetic field will be more. Next is the nature of the core. What type of material is used? Different types of ferromagnetic materials are used, which have different values of permeability, different values of susceptibility, different hysteresis characteristics, hysteresis curves. So depending on that, the magnitude of the electric field produced, the magnitude of the magnetic field produced by the electromagnet will be different. So ferromagnetic material are the obvious choice for design of electromagnets because of their strong form of magnetism as compared to paramagnetic material. Then intensity of magnetization and permeability should be more, and it should also have high susceptibility. So these are some of the important properties. And with respect to the hysteresis curve, low coercive materials are suitable for in case where AC type electromagnetic devices or electromagnets are used, where alternating current is used, and the area of the hysteresis curve should also be less, which will lead to less energy wastage. So these are some of the important properties associated with the design of electromagnets. Okay, so again, the same properties which we have discussed, the important properties associated with magnetism, permeability, susceptibility, intensity of magnetization, magnetic flux density, hysteresis curve, all those things are coming into play. Okay, so these are some of the important concepts related to electromagnets. We have tried to cover it in short because there is a lot of other things to it, which maybe in the electricity and magnetism we will discuss it in detail. Here I just wanted to keep it short. In a quick way, I wanted to cover it so that we can carry forward our discussion related to electrical machines. Okay, so this is about electromagnets. So we've discussed permanent magnet and electromagnet. So I hope you like this video, and please subscribe my channel Engineering Tutorial for more such videos related to engineering, science and technology. Have a great day. Thank you very much.